Hello, amazing people. Welcome to this electrifying session of Qubits where innovation meets inspiration. I am Anshika and I'm thrilled to be your host for today's session. Hack the Mountains is not just another hackathon, it's a vibrant community that brings together passionate individuals from around the world to innovate, collaborate, and create. Our mission is to provide a platform for budding technologists, developers, designers, and entrepreneurs to showcase their skills. And with this, it's time to dive into today's session, Unleashing Generative AI. We are incredibly fortunate to have Avinash with us, a true expert in the field. Avinash is an Amazon open source SME and a cloud support engineer at AWS. With a wealth of experience as a hackathon organizer, judge, and mentor, he brings a unique perspective to today's discussion. Please join me in giving a warm welcome to Avinash. Avinash, the floor is yours.
So, hey, hi everyone, and thank you, Anshika, for such a great introduction. As you mentioned, today we'll be learning about generative AI. So, in the today world, everyone is talking about generative AI, chatbot, ChatGPT, and all. So, we'll do a short session on the generative AI today, building generative AI application with Amazon Bedrock. So, without wasting any further time, let's get started. So, today, as the session is building generative AI application with Amazon Bedrock, in this session, we'll cover lot of things. Like we'll start with the overview of Amazon Bedrock, introduction to generative AI and foundation models. We'll cover the Bedrock architecture as well. After that, building and training foundation models with Bedrock and deploying and serving generative AI application in a serverless manner. And apart from that, as you might have noticed, my sessions won't go without a hands-on. So we'll have a hands-on. We'll create one application that will generate codes for us. So let's get started. So first of all, let's get started with the introduction to generative AI. As you know, generative AI refers to the artificial intelligence model that can generate new data such as text, images, or audio based on the pattern that they have learned from the training data. So this part is important. They can only generate from the pattern that they have learned from the training data. So what are foundation model? Like in the initially I mentioned about foundation models. So foundation model are large LLM models, are multimodal models that serve as a foundation for building various generative AI application. If we take the example of ChatGPT or GPT-3, they are built by more foundation models, for example, BERT by Google and T5 by Google AI. So these models are trained on a vast amount of data to learn patterns and relationship, enabling them to generate human-like text. Apart from that, answer question, summarize information, and do a lot of things that humans might take more time to do. And it will be like waste of human resource to do such tasks. That's why we have AI here. So applications of generative AI. So the rise of AI has opened up many possibilities for various applications, including content creation, virtual assistants, code generation, data augmentation, image generation, even generating a complete movie. So the applications of AI are vast. Now let's learn about Amazon Bedrock, which is a application provided by Amazon. It's a fully managed service. It has a stable resources. Apart from that, it has support for various model architecture. So as mentioned, Amazon Bedrock is a fully managed service that allow developer to build, train, and deploy function models for generative AI applications. It provides a comprehensive set of tools and services for working with foundation models, for data preparation, for model training, until deployment. So Bedrock simplifies the process of building and deploy generative AI application. So if you have to build your own generative API application, let's say you have to build the application like chatbot, it takes immense amount of resources like the compute resources that you needed, the data. But with the help of Bedrock, you skip all those things and directly focus on the code that you want to develop. So it leverages fast computing resources and scalable infrastructure to enable efficient training and inference for the foundation model. It can, like, you can build application to perform multiple tasks. It can deal with text, it can deal with images, audio, and other lot of factors. Now let's take a quick look at the architecture of Bedrock. So when we talk about architecture and its component, so it involves data preparation, model training, model management, model deployment, and APIs and SDKs. During this particular session, we won't be going through data preparation, model training, model management, model deployment, because they take a lot of time and it's a more comprehensive topic. If I have to speak on that, it will take a complete day. We'll directly focus on the APIs and SDKs that are available to us. We'll use that to build some application that we can run at our end. So, about the data preparation, it provides tools for ingestion of data, cleaning of data, and processing of data, so that the data that is raw, unstructured, it become ready for model training. Next, the model training, it provides like efficient training foundation data sets, so that whatever model with that positive data set, it can be trained. And then it provide model management, like version control systems, so that we can efficiently manage our models. And finally, we can deploy our models on the SageMaker, in Bedrock, and other services if we want to go with EKS, which is Kubernetes, and Docker, etc. Finally, APIs and SDKs, we'll take a look at that in the later section, because we will be using what it is, API and SDKs. Now, building and training foundation model with Bedrock. Why you should choose Bedrock to build such models? Because it's a unified environment for model building. Data preparation flexibility come with multiple tools, so that your data become ready to be used for model training. It has customizable model architecture, and it has a more efficient model training. And you can also deal with the hyperparameter optimization. We'll take a look at what are the different hyperparameters that are available. We basically use these hyperparameter to improve the efficiency, to improve the scoring of our application, so that the content that is generating, it's not hallucinated, it's more suitable to the human use. So there are multiple fine tuning parameters that are available, like temperature, K value, and others. So next we have deploying and serving generative AI application. As mentioned, if you have to build your own chatbot, or if you have to build your own generative AI application, it's a huge task. You need resources like compute power, memory, and then you need data and all. But with the AI release, you can directly deploy your model. You can scale it with the as your user base scales. You can have APIs and SDKs that you can provide directly to your user, so that they can use your application. It comes with monitoring and logging capabilities, like we have CloudWatch and all, and then it's secure as well. Uh, let's not bore you with the theory. We'll directly go to the cool stuff here. So we'll do a hands-on on building a code generation application with Bedrock. But before that, I will show you a few other things. I hope you guys can see my other screen. Yeah. So this is Amazon Bedrock. With the help of Amazon Bedrock, we can build generative AI applications. So it's the easiest way to build and scale generative AI application with foundation model. So I told you, foundation model, they are the backbone of generative AI application. In Amazon, we have multiple foundation model from the industry leaders that we can use. If we take a look, so this is the Bedrock. Let me give you a view. There are many foundation models that are available. In my case, I am using some models. I have already enabled them. Like we have Claude 3.5, Sonnet, 3 Sonnet, Haiku. Apart from that, we have models from Anthropic. Using these all models, we can generate text, we can generate images, and perform a hell lot of stuff. So in this particular session, what we will do, let me draw things here. So our today goal will be, let's say this is our generative AI application. This application task is to generate code. Whatever code we say, this application will generate the task. We'll code this particular generative AI application by using the SDKs. And then we want this application to be accessible to all the people. So how we can do that? We will be using API gateway. So let's say this is our API gateway. We'll call it like this. So using this API gateway, we will be calling our generative AI application to give us the data. So the structure will go like this. Now let's jump directly to code. If at any point of time you don't understand the code, please feel free to let me know. I have already coded the application so that we don't face much issues. So as mentioned, the Amazon Bedrock, it's available in APIs and SDK. For this particular session, I will be using Amazon Boto 3 API for the Bedrock. So how it goes? This is the basic API that is available to us to invoke a model with a single prompt. So this is the example. We will be using Boto 3 client. Here, when we are invoking the client, first we have to make a client. So here, using Boto 3, we have made a client for Bedrock runtime. And these are the parameters that it takes into picture. First, it needs a prompt, then the tokens to sample, then the temperature, and top 9, top P. So information about these temperature, max token, top P. These are the inference parameter that we can optimize to improve the output of our generative AI application. Information about the same is mentioned here, like temperature, why it is needed, top K, and top P. We'll discuss about it later. Let's directly jump into the code. Just remember these things. Like this is the basic structure that we need to follow. Here is the Python code. I will explain you the same. So first of all, in line 1 to 4, I'm exporting some basic libraries that are out there like Boto3, JSON, Boto Core, and data time. We need data time. Why? We'll take a learn about later. For this lecture, I'm not including this functionality, so I will remove the data time, but we can have it later. Then I have created one function in Python. We create function using def. So it's a generate code using Bedrock. As mentioned, to invoke the particular model, we need prompt text. So here prompt text is passed so that we can have inside it the body. This is the same architecture that is defined here. The body we need to pass. So in here, I have defined one prompt text. So when we are giving our text to some generative AI application, basically when we talk about the Bedrock, it basically takes about two things. One is the human, like when human is saying something, when it starts with the human, so it means human is saying something, and then assistant, Bedrock has to generate something. Here, human, then right language we are passing. Let me again. Here I have created one function. This function takes two parameters: message, which is of type string, language, again it's of type string, and then it is giving us back output in the form of string as well. So here the prompt, then I have defined the body. In the body, I have passed the prompt from the here, then max samples, then temperature, top K, top P, and sequence stop sequences. Whenever it initiate, so what it happens? Initially, it will start with this human. Then Bedrock will generate some text. Again, when human will come, so it will stop. So that's the stop sequence. Now you know this basic Python code. Try and accept block to handle the errors. Here I'm creating Boto3 client as created here in the API. So client equal to Boto3.client, and then we have to give the service name, which is Bedrock runtime in this particular case. So here, this Bedrock, in this particular line, I have created a client. Bedrock runtime, region is US East 1, North Virginia in my case, and then have configured few things like read timeout and retries, which is maximum 3 if any error comes. Post that, whatever, now we have to send the response. So response Bedrock dot, we have to use the invoke model function. As discussed here, we have to use the invoke model. So here response equal to, this part is the client, and then dot invoke model. It takes three four parameters. First it takes the body, which is defined here, then it takes the model ID, which we define here, except the type which is using its application by JSON. So this particular part we have given it in JSON format, and finally the content type, again it's JSON. Similar thing are done here. We have our model, which is anthropic.cloud v2, and then response we are getting it from just few formatting, and here we're returning our code that will be generated by this particular Bedrock application. And then exception handling. Further, this is the main lambda function. Like in Python we can have many functions, as many we defined. Then there is one main function under which everything will be executed, so its lambda handler is the main function here. Event and context will be used to pass the input. We have defined event equal to, we are passing the event as a body from here. Then we have message, with this will be given input by the user. Language again by the user. We are printing message and language. This is just an standard mechanism that I use to handle the error. If any error come in this particular piece of code, to see whether the input is passed successfully or not. So that's why I do this thing, so that in my CloudWatch logs I can see what is happening. Then we are calling the function that was generated here, generate coding using Bedrock, and then we are passing the two parameters that it need, the message and the language. After that, simple handling. As I mentioned, in this particular architecture, we have Gen AI application. In this case, instead of creating a generative AI application, fully fledged, like first by giving the data, then preparing the data, training the data, we are using predefined foundation model, which is this one, Anthrop Cloud V2. we will be using this model, and we are using APIs and SDKs. So this is a Boto 3 SDK to particular call this model to interact with this model. This part is defined, lambda function is good. Now one thing, like if I want to give this particular lambda function or this particular model to you guys, so I won't be giving my AWS credential to you to run this model. That will be like, if I give the credential, you can do anything in my account. So this is not a best practice. What we do, we give a public URL, a front-end URL to the general public. In this case, I have used API gateway. So using API gateway, I have created an API to invoke this particular Gen AI application, in which this particular case it's my lambda function. Here, let's head over to API gateway and see what I have done here. So here I have created one API. I have money API. So I have used HTTP API directly build. So we have to give the name. We'll call it test. The review and create. Everything is good. So after that API, when we have created API, it takes some basic function. It can be get, post, put, delete. In this case, we want to send some data, like we want to send message and we want to send the language. So we have to generate a post type of method. So currently this one I am having here. This is my API. This default. Currently it doesn't have anything. There are no routes created for this. So I will create a route of type post. And then we can define a route where it will be, like any endpoint. So let's say test only. Then I have this post method. Authorization, if you want to your user to be authenticated first, whether they have permission to access the resource or not, you can do that. But in my case, I won't be doing that. I will directly hand to the integration part. So attach integration. Here we can define what we want. So here lambda function, I have already done that. So in this case, I won't be doing that. I will just cancel it. And I don't need this particular API as well. So I will delete this. We'll go with the API that is created previously. One thing in AWS, whenever you are done with something, you don't need it anymore, delete it. Don't keep it. Otherwise, it will cost you. So this is the API in our case, the Bedrock API. I have created two stages, the default and the dev one. So in this case, we will be using the dev stage. So I hope the code part is clear. It's a simple basic code. We are invoking the already existing Bedrock model, the Anthropic Cloud V2. We are giving the parameter here. We are using this particular model to generate some text, not the text, to generate code. Let's see now how it goes. So as mentioned, I have my API gateway. I will be using this particular URL to invoke it. So in my case, I will be using Postman to run the code. This is my Postman. The API type is HTTP method is post, the complete URL, and then the endpoint. In this case, I have created the endpoint as code generation. Then we have to give the two input parameters. As if we take a look at our particular code, it accept us to provide two input parameter. The one is message and the other is language. The first one event, it is passed from here, the body that we created here, but it needed two parameter from us, the message and the language. So here in my particular this, I have given the endpoint and the complete endpoint, and then in the body I have passed the two key parameter that it needs, the key which is Python and the message implement binary search. Here we can write anything, like right now we are asking the Anthropic v2 cloud API to implement a binary search. Let's run this code. So here is the implemented Python binary search. Right now the output is not that great, it's not in well formatted code. If I go to raw, again same preview, visualize, the visualization is not there. So the code, we need to JSONify it, prettify it to make it more clear. So instead of generating the code here, what we can do, we can leverage another application. You might have heard about the another AWS services. You might have heard about the S3. So S3 is a object storage that you used to store. So instead of returning it back to the user, because it's a Python code, indentation error will happen. Apart from that, the code will come in this format, so we won't be able to understand anything. So what we can do, we can leverage S3 To store the result here, instead of returning the result back to the user, we can leverage S3. So we have to modify this particular code to perform that action. Let's go through the same. So for that, first of all, we need an S3 bucket. So in my case, I have already created one S3 bucket. So my S3 bucket, yeah, here is the bucket. I will first clear the data from here. So currently my bucket, which is named as HTM bedrock, is empty. I don't have any object. I will modify this particular Python code to store the result back into S3. So let's do it. Okay, so before the Lambda handler, I will be creating one more function to save the code to S3. So let's call it save code to S3 bucket. Okay, save code to S3 bucket. And then we will be giving the bucket name as a parameter here, the input parameter. We need three things here. One code, which is passed from here, the line number 25. Then we need S3 bucket name and a bucket key. So S3 bucket and S3 key. Key will be the path here. This is the Lambda function. Again, to perform some action, we need to create a client. As you can see here, I have created a Boto3 client. Uh, I have used Boto3 to create a Bedrock runtime client. So Boto3.client, I will be again using the same thing. So S3 is the variable equal to, again, we'll be using Boto3 dot client function, and client, we want of type S3. Okay, so client creation is done. Next, what we can do, we have to put the data or the code into a file and store it in S3. So try and catch block, because error handling is important. Inside the try, we'll do S3. We use the put function. So S3 has many API calls that are available. Put API call is there to put the object into S3. So we'll use the put API call S3 dot. So API call is S3. Let me search for the API call. I think it's put object. Yeah, the API call is S3 put object. And not this one. I need it to the CLI way. So it's put underscore object. The API call will be using this one. Okay. So S3 put object API call. Then it need the bucket name. This will be our S3 bucket. The next thing that it asks for is the key. This is going to be S3 key. And lastly, the body. In our case, the body is going to be our code. These are the parameters that it needed. So we have given all the parameters. If we take a look at this, the parameter that it needs, put object, it asks for the bucket, we'll give the bucket name, it asks the key. So the one which are in bracket, the list bracket, these are the optional one, we can exclude it, but the one without the bracket are the mandatory one. So put bucket API call we are using, we give the key. From here we give the, apart from that, bucket name, and then one more thing, which is the body. Let's go back to code and finish it as fast. So here in the try block, I have defined the API call s3.put object. Bucket is going to be S3 bucket, key is the S3 key, and body equal to code. Then let's print something to see it's happened or not for the error handling purpose. If this part is done successfully, let's say code is saved to S3. Then let's do the exception handling. Why is not autocomplete? Accept exception as E. We are capturing the exception and we'll print the exception. Or instead of printing the exception, we can just say that error while saving the file to S3. This part is done. Then we have our lambda function. This is good. We have our code. This is also good. And this. So now one more thing here. Here what I have given is S3 bucket, but I haven't passed it anywhere. Code part is passed. Even the key is not passed. So while calling this function, I have to pass all these parameter. So generated code, if generated code equal to, and now this particular thing from date and time, this will be uh, coming handy now. So what I want the key to be current time. So let's do that so that whenever we are saving the file, we know this particular file is saved at what time. So that's why we will be using current time. Here we'll give multiple output now. So if I can handle this particular code now, we don't need this part now. Okay, need to modify this particular if else block now. This is going to be daytime now, and I will just copy it. I have the function ready. Okay, this part is done. Now the next part that we need is S3 key. S3 key is going to be the current time. So it's a function that I'm using, code output slash current time is .py. This will the name of my file that will get saved to S3. Next part, the bucket name. So format is S3 bucket underscore bucket variable we have getter. Here we have to give the bucket name. In my case, the bucket name is, where is my S3? Yep, this is the bucket name. The HTM hyphen bedrock. Let me update it same here. Done. Now we have to save the code to S3. So we'll be calling this particular function save code to S3. Let's give the parameter. Again, inside this, we'll be calling the second function, which is generated code, this particular one. And then we have to pass the S3 bucket and S3 key. With this one, we are almost done. Save code to. So this part is done. In the return, I don't need anything here. So we'll comment out this particular part of code. We are not jumping any code. In the else part, I will say, let's say no code was generated. And in the return part, we'll keep this return status will be, let's say 200. Body JSON return failed to generate code. Instead of this, we'll say code generation in process. So by modifying this particular code, instead of getting the output directly here in my Postman, which is not a good way, because when we try to paste this particular code into any text editor, let's say, or any uh, code editor, let's say visual editor or Sublime, this particular thing won't work. So instead of this, let's have a proper Python code. So to do that, what I have done, I have generated one more function which will save the code generated to S3. So this is the function save code to S3 bucket. I have passed the code which was generated here, the S3 bucket, S3 key, and then I have created a client to actually perform this action, to perform a put object action. This part is done. Now let's test this code. Same, I will keep the key as Python and message that implement binding search. One more thing, whenever you are done with this, you should deploy the function, and I will discuss one more parameter here. So this is the lambda function here in between. Here is the lambda function. Lambda function is in actually between, not here. So here. So here, this lambda function, it's actually S3 is also in between. So we have multiple services involved now. So I'm writing multiple things now. Initially, we started with just a small thing, but now we have multiple now. So this is the architecture that it has become. We'll call it S3. So lambda is doing this thing. We'll put one block to lambda. Done. So what will happen using our API gateway? We'll call the lambda function that is created. This lambda function will create and as well as invoke the generative AI application, which is Bedrock in this case, and it is using Cloud V2, which is content generation model. So this will get the output back to lambda function, and lambda function will save it in S3. So lambda function, it needs permission to perform this particular action to save the data into S3. For this, it has a role. In this case, here is the role. So for the simplicity and for this lecture, I have given this particular IAM role full access, but we shouldn't do that in ideal scenario. We should follow the least principal privilege. Now let's run this code again. I have changed the code, the- made the changes that is needed to deploy this particular function to, to actually generate the output in a file format .py in the S3 bucket deployed. And now instead of testing from here, we'll test from the postman. Let's run this code again. So it said internal server error 500 with the code. Now we need to find out why this internal server error occurred. So we can check it using Python, the logging mechanism, which is CloudWatch in this case. Let's see CloudWatch what it says. This is the latest stream that is produced. Here it says syntax error, lambda function unmatched, lambda function line number 59, it failed. Line number 59, it failed. Exception analysis, error line number 59, syntax error. Okay, let's see our code. What has happened here? Okay, so what happened here? I forgot, like I commented this particular code, this particular bracket, it lies with the return block. It was left uncommented. Let me comment it, deploy the code. So whenever we face any error with the particular lambda function code or anything, CloudWatch logs are there to tell us why it happened. So it said unmatched this particular bracket. So I commented it, deployed my code, and let's run it again. So request is going through, which means no error. This is good sign. It returned null in this case. Let's see the S3 bucket now. There are no object that are generated. It means again our code has run into some error. I will again run it to verify the output. And in the meantime, I will again check the logs. Let's check the latest log stream. Okay, it is saying, I told you like implement binary search. This is the message that we are passing. So here I have printed it. Okay, now if we take a look from the CloudWatch, it says error while saving file to S3 bucket. So our code generation was good, everything was good. So it has faced issues while saving file to S3, which means it failed in this particular block. Let me re-verify it. Okay, this part looks good to me. I have just closed the space here. Now let's deploy. I will close the space here as well. This shouldn't generate any error, but just because code seems good to me. Deploy, and we'll again test it using, of course, our postman. Again, null. Just re-verify the code. Okay, I just modified the code a bit. I have like code in my hand, so I use that one. Now it's deployed and again run it. The request is being sent. Now this should work without any issues. So it said code generation, which means this particular function is being implemented now. It didn't failed in this part. It went to the end and it returned this particular part. So by this, we should have one file in our S3 bucket. Let me refresh it. So yeah, inside the code output, we have this one, one more file. Actually, two was generated. I ran it two times. Let's see the time. It's 39 and it's at 40. It means the previous code, even though it returned null due to my maybe bad code somewhere, but it actually saved the file. So let me check the latest one, which is this one. We'll open it. So here the code is generated, and just not the code. So here is the code to implement binary search. It gave the Python code completely. It gave the list, and then it also gave the steps. So right, by using this particular application, we'll call it serverless application. Why? Because I have used Lambda. Lambda is serverless. I have used API gateway. API gateway is serverless. So we have used two serverless application here. So using these two applications, we generate a generative AI application that can generate code for us. Let's test something else. We'll call it, instead of implement binding search, let's say implemented linked list. Let's run this with new different parameter, like view different prompt. In this case, we are saying implemented linked list. Let's run this. Again, code generation, which means S3 bucket should have file now. Let's see the same. So here in my S3 bucket, I have one more file which is generated at this particular timestamp. Let's see this. I'm opening it, downloaded. Here is the Python code to implement a linked list. So again, it will give the instruction. This will implement the core linked list functionality like insert, delete, traversal, printing the list, and it can further be extended. So that's all in this particular lecture. Yeah, that's all in this particular lecture. We learned about the generative AI applications to generate different type of things. We used Lambda function and Amazon Bedrock and API Gateway to generate an application that returns us the code. So in the conclusion, why should we use Bedrock or Amazon or another? It gives you seamless integration. Like I haven't created any model at my end. Like I didn't provide the data, I didn't train the data, cleaning, and I haven't went through all of that hassle. I just use the available models, and I just focused on the coding part. So what happens when you are working on something, you are a developer, you shouldn't focus on the infrastructure or other things. You should focus on the code. That's what happened here. I focused on my code rather than building the model. Enhanced functionality. Then apart from that, there's scalability and flexibility. Let's say multiple users are invoking my Lambda function. So what will happen? Lambda function will automatically scale because it's a serverless application. And then, of course, Lambda function is a cost effective. You will be in charge only for the invocation that are happening in your account. So that's all you can try at your end. You can use documentations, like there are multiple documentation if you go here. So in my case, I used Boto 3.1. So there are multiple examples that are available here. Even the examples are available in Bedrock page. If you go to the examples page, let's say what I want, we'll call it question answering. So we can make a question answering bot here. So here again, this is the Python code that it needs. It uses again this one. It's a question answering bot. Using this documentation, we can create as many generative AI applications that we want. So feel free to try it at your end. And if you have any questions, any queries, any concerns, please feel free to ping me. So that's all for today. In like, if we hope to conduct one more sessions on generative AI, then we can go with the chatbot creation and the image creation. But that's all for today.
Thank you so much, Mr. Avinash, for being here with us and imparting our audience with the knowledge that they'd require if they happen to build any projects on the similar tracks. For now, we have crossed over 3,000 registrations on Hack the Mountains. So, dear audience, if you happen to revisit this or use it in future prospects, please don't forget to tune into our socials. Everything is in the description. And Avinash also has given their socials in the description itself. Their wealth of knowledge was quite evident from the way they conducted this session with that clarity. So once again, thank you with you know on the behalf of entire HTM team, Avinash.
Thank you, Anshika, and thank you, Hack the Mountains. It has been a nice day to hear. It's Sunday, of course, but then again, a nice way to interact with the people and to share something that I know with the audience. It's always a great learning experience for me as well. Like while running something, getting into error, then solving that error. So it's a good experience. Once again, thank you for having me here.
Yeah, rightly they say what you build is building you. So with this note, it's a good time to wrap this session up. Thank you everyone for being here with us.
Thank you. Bye bye.
Bye bye.